Let's set the scene. The year is 1601. Johannes Kepler, a truly brilliant, but let's be honest, financially struggling German mathematician and mystic, is mourning the loss of his patron, and he finds himself wrestling with this huge problem, trying to reconcile his deep, mystical belief in a perfect geometric universe with this immense, chaotic pile of astronomical data left behind by his former boss, the legendary Tycho Brahe. Now you have to understand, this wasn't just some professional challenge for Kepler. This was a profound crisis of faith. It was this massive collision between the world as he passionately believed it should be and the world as it stubbornly, undeniably appeared to be in the cold, hard numbers on the page. For almost 2,000 years, everybody who was anybody, the scientists, the philosophers, all following Ptolemy and Aristotle, agreed the heavens were perfect, they were divine. And the language of God, well, that had to be the perfect circle. So naturally, planetary orbits had to be circles. This was the beautiful, elegant theory that Kepler desperately wanted to prove. But what he had, spread across a mountain of pages, was Tycho Brahe's data, the most accurate astronomical observations ever made by a human being. And this data, well, it was messy, it was chaotic, it was imperfect, and it just would not fit that perfect divine model. Okay, so this is where our story really kicks off. Kepler's defining moment wasn't some sudden flash of genius. It was this slow, agonizing realization born from this exact conflict between his faith and the facts. He inherited a paradox, this mountain of data that completely contradicted his deepest beliefs. This inheritance, you see, it wasn't just numbers. It was a challenge that was about to change his life, and frankly, the course of science forever. The big turning point for Kepler was a complete 180 in his thinking. He finally realized he'd been trying to shove the messy data into his beautiful theory, but the data just wasn't having it. He figured out that the real path to finding the universe's harmony wasn't to force his idea of perfection onto it, but to actually give in to the imperfection, to really listen to all that noise and all those little errors we're trying to tell him. And this new way of thinking, it led him straight into what you can only call a war. For nearly a decade, Kepler waged this computational battle with the planet Mars. And this wasn't some cozy academic project. The guy was constantly sick, always broke, and just intellectually exhausted. Mars, with its really difficult to predict orbit, became his obsession. It was the ultimate test of his new promise to just follow the data. 70. Just let that number sink in. 70 is the number of times Kepler calculated and then recalculated the entire orbit of Mars. And remember, we're talking about a time with no computers, no calculators, nothing. Every single calculation was done by hand, page after page of brutal arithmetic, probably by candlelight. 70 complete attempts, each one a different model, each one a massive undertaking, and every single one of them a failure. That number isn't just about effort. It's about a decade of just relentless systematic grit. This wasn't just him being stubborn either. It was a system, a really disciplined method we could call the iterative rejection loop. Here's how it worked. First, he'd propose a new model using all sorts of shapes, ovals, circles, you name it, drawing on everything he knew about geometry, physics, even music. Then he'd do the grueling calculations to see where his model said Mars should be. Next, he'd compare his results against Tycho's rock-solid data. And of course, he'd find an error. And finally, here's the most important part. He would throw out his own beautiful model and start the whole painful process all over again. He was basically eliminating every wrong answer, so the right one had no choice but to show itself. And this brings us to the climax of his war with Mars. After years of this brutal loop, after dozens of failed attempts, he finally came up with a model that was almost perfect. I mean, so close he could taste it. But almost wasn't good enough. Not for Kepler, and definitely not for Tycho's data. There was this one, single, tiny, nagging error left. An error that would demand an unbelievable sacrifice. 8 minutes of arc. To give you some perspective, a single degree in the sky has 60 minutes of arc. So this error was tiny, a sliver of the sky so small that any other astronomer would have just written it off as a mistake in the observation. But Kepler knew how good Tycho's data was. He trusted that data more than he trusted 2,000 years of tradition. And this tiny, unbearable flaw was like a ghost in the machine, telling him his model wasn't just a little off, it was completely, fundamentally wrong. So here it is, the ultimate choice. And it's a question at the heart of all science, really, all quests for truth. Do you cling to a beautiful, elegant theory that's been around for 2,000 years and almost works? Or do you trust one small, ugly, inconvenient fact that tells you your entire foundation is rotten? What do you do? For Kepler, after that decade of struggle, it wasn't even a question. There was no choice at all. His entire method was now built on intellectual honesty. To ignore that 8-minute gap would be to betray everything he learned in his war with Mars. So, with what must have been an incredibly heavy heart, he threw out years of his own work and abandoned the idea of perfect circles forever. And out of the ashes of that failed theory, he built something completely new. You see, his sacrifice wasn't an end, it was a beginning. It led him to a huge revelation, a brand new blueprint for understanding the whole cosmos. And it's the systematic philosophy born from all that struggle that we're calling the Kepler Equation. Now, it's really important to get this straight. When we talk about the Kepler Equation, we're not talking about a single math formula like E equals mc squared. We're describing the mindset, the entire philosophy that made his discoveries possible. It's the radical belief that the universe isn't some mystical, unknowable thing. No, it's a knowable machine. A complex one for sure, but a machine whose code can be cracked, whose patterns can be found, if you just use rigorous math and unwavering honesty. This whole philosophy really rests on 3 core principles. First, the subservience to data mandate. That's the rule that says the data is the boss, period. It's what forced him to junk his theory over that tiny 8-minute error. Second, the Geometrical Harmony Protocol. This is about using math not to prove what you already think, but as a tool to hunt for the real structure hidden in the data. And third, the universal law projection rule. This was huge. It's the idea that the laws of physics that work for Mars have to work for Jupiter and for Earth and for everything else. His personal struggle became a universal truth. And it all comes back to this one game-changing idea. The universe is a knowable machine. By ditching the idea of a perfect divine cosmos and embracing a mechanical one, Kepler basically empowered all future scientists. Because if the universe is a machine, that means it follows rules. And if it follows rules, then those rules can be discovered. The mystery could actually be solved. So this brings us to his legacy, which is just massive. Because Kepler's lonely, decade-long fight didn't just solve the problem of Mars's orbit, it literally laid the foundation for modern astronomy and what we now call the scientific method. His own personal journey from a mystic to a methodical scientist was a preview of a huge shift in how humans thought about the world. You can see just how critical he was on this timeline. First, you have Copernicus, who had the big idea that the Earth orbits the sun. But his models still used perfect circles, so it wasn't that accurate. Then comes Kepler. He's the one who provides the mathematical proof. He figures out the elliptical orbits, the laws of planetary motion. He builds this indispensable bridge that allows Isaac Newton to come along later and explain why it all works with his law of universal gravitation. Honestly, without Kepler, Newton's apple might have just been, well, an apple. So, what's his ultimate legacy? It's bigger than his 3 laws. It's the method itself. It's this idea of empirical subservience, a fancy way of saying data is king. It's the non-negotiable principle that hard evidence has to win out over elegant theories, over what the authorities say, and over your own personal beliefs. He proved that tough math combined with brutal honesty towards data is the key to any real breakthrough. And this all leads to a powerful lesson for all of us. The beautiful is often the enemy of the true. That idea of perfect circles was beautiful. It was simple, elegant, poetic. And it was just wrong. Kepler's story is this amazing reminder that we have to be willing to sacrifice our most beautiful, cherished ideas on the altar of ugly, inconvenient facts. The real takeaway from his life, the challenge for us, is this: systematically reject what conflicts with the evidence. Don't explain away the little errors, the noise, those 8-minute discrepancies in your own work and in your life. Dig into them, question them, and commit to the brutal, honest, and often thankless work of finding the truth, no matter how much you wish it was something else. So in the end, Johannes Kepler built his legacy on the profound realization that the beautiful is often the enemy of the true. His equation, his philosophy, gave us a systematic blueprint for proving that patterns reveal everything, but only through relentless mathematical endurance and absolute empirical honesty. His life's work leaves us with a single, timeless rule for any search for knowledge: mathematical honesty is the ultimate source of predictive power.